So 7.5 is the last section in chapter 7. Is about comparing two population proportion with confidence. So now we are comparing. So let me see if what do they need us to compare. So right now is an example comparing two population proportion. We're talking about introduction. So in 2002, it looked like the old example. A Pew poll based on a random sample of 1,500 people suggested that 43% of Americans approve the stem cell research. So this is here is in 2002, and now next will be in 2009. So it means you are comparing two population, one in 2002, one another will be in 2009. So in each year, they having different value for us to record, and then you compute it the same way, okay? So in 2009, a new poll of a different sample of 1,500 people found that 58% approved. So it looks like this would be the P or P hat in 2002. This would be the sample N 1,500. We got in having the same people, or like not the same people, the same amount of the people, okay, and but different percentages. The question is, did American opinion really change? Right, we want to see if that happened, is it really changed, or do the sample proportion differ from just by chance? So could the population proportion be the same even though the sample proportion are different? So let's answer that question by let's do some process. And remember, for this 7.5, here is we are learning about comparing proportion. Okay, so even if two population proportion are equal, that means they're having the same. I think if it might be the same sample, 1,500. The sample proportion drawn from this population are usually different. Okay, so confidence interval are one method for determining whether different sample proportion indicate there are real differences in the population proportion. So they give us the hint confidence interval will helping us. So basic approach, what we're going to do is they give us the kind of the idea. Our comparison of two populations proportion will be based on the following formula: p hat minus p hat 1 minus p hat 2. So p hat 1 in this case is in 2002. P hat 2 in this case will be 2009. Okay, so this statistic is used to estimate the difference between two population proportion. So this would be the value that, like I said, p hat will be estimating for p. So if in the problem they're talking about p hat, which is the sample of sample, then we're using that formula. And if they're just talking about just the sample, like represent for populations, then we're using that one. They've given us two formula. In case that happened, then you're going to know which one to choose. So find the confidence interval for the difference in proportion, P1 minus P2. So in this example, as I understand, is we're talking about P. Okay, so P1 will be the percentage, which is about 43%, and P2 will be 58%. Second, you check to see if 0 is included in the interval. So if 0 is in the interval, this suggests the two population proportion might be the same. So actually from here, they can put, they set that equal to 0. Okay, so if the 0 in the interval, they suggest that. So here again, this is just the approach. It's not really like we're doing the math here, right? This is just the idea. So for that problem right here, I would like to guide you walk through this information so that you know like the idea of it, but it's not actually solving this yet. So okay, so later we're gonna solving for this one. You will see it. So next, if 0 is not in the interval, the confident interval tell us how much greater one of the proportion might be than the other. So here we having the following general method. So after walk through that, you'll know how to identify P1 minus P2, stuff like that. Then we're going to using finding the standard error for those proportion difference. So the confidence interval for two proportion has the same structure as the confidence interval for one proportion. So this time we are doing for two. So what you're going to do is you're using this formula: statistics plus and minus statistic, which is the percent, right? Percent of that year. So we add or minus Z star, depend on like they're asking for 90% or 95% or 99%, depend. Then you have to using the same and the different Z star. SE would be the same thing. So for this case, we are doing for the difference of two proportions. So this would be the formula. It looks complicated, but actually when you plug in the value, okay, you plug in the value correctly, then you have to do slowly, otherwise you do the wrong math. So and Z star is chosen to get the desired confidence level as we did for one proportion, just similar, okay, similar to 7.4. Putting these two together, we see that the confidence interval for the difference of two proportion is the following. You got P hat 1 minus P hat 2, or P1 minus P2, okay? Plus or minus Z star times square root of P hat 1 times 1 minus P hat 1 divided by N1, and so on. So some people might say, okay, it's so confusing. When do I using P? When do I using P hat? Actually, P and P hat kind of really equal, the same. They estimate P hat estimating for P. So it's I don't really like care about like when you put in the formula is a P or P hat, but you need to understand that P hat is a sample. Proportion is mean when you found P hat, when they given you a sample, then you are having a smaller sample, or you having the percentage of that sample, okay? And those values will be interpret the entire population. That's what it means. And here using TI-84, for those people who like to using TI-84, please spend time to type this in. There will be two columns for you to type in to compute. But because we are all purchased StatQuant, so I would like to using StatQuant instead. Right. So using StatQuant, what do we do is we go to stat and go to proportion stat. It's just like in 7.4 finding confidence interval for one proportion, right? Go to proportion for stat. Instead of one sample, we are doing two sample with summary. Okay, so the difference is only here. And then we're going to enter the number of the successes and the sample size for each sample, and click the option confidence interval for P minus P1 and adjust the confidence level. So later I'm going to show you how to enter it. And before we are doing the step again, so for that we still checking for central limit theorem requirement. So it looks like it's just the same thing, but the things that you just add like both sample are randomly and independent. And you also testing for this for proportion 1, and then you're testing for proportion 2 times. Okay, don't skip this. And checking conditions. Again, this step you multiply it by 10 to see the estimate of the entire populations. And independent sample, the sample must be independent of each other. This is just give you the definitions. but you can stop right here and then you can start finding SE, okay, like going backward. So this 3 step, and then look, and then using this formula, slide number 7 to find SE, if you compute by hands, if you like to compute by hands. Okay. Okay, here they having different example. Let me go back to the example that we have at the beginning. Hopefully they have enough information. They having so they do have enough information, but they give us the percentage. Our job, we have to convert this percentage into the a number, right? The number we call that will be the number of success. So now I'm going to open up step one. This is 43%, and we have 58%. So let's try that. So let me minimize this down. Step one right here. Let me close this. Okay, we have this. Go to stat, and we go to proportion stat, two sample this time. With summary, number of success for sample 1, we are having 43% of 1,500. So we take 1,500 times 0.43. We're having 645. And here observant is 1500. And here we are having what percentage? I think 58, right? 58%. So you take 1500 times 0.58. You got 870. So 870. And here we are 1500. So we're not doing chapter 8, we are doing chapter 7. So we click this, and let me see what is confidence interval that they wanted. So look like for this one, they don't give us enough information, right? So depend, like they want us to find like 95% or 99%. So I make it up. So I'm assume that to be 95% confidence interval. So let's see that. So on the test, I will give you specifically the question. It's not like introduction like this. So I make that become 95 like this, and let's compute that. So when we click compute, we are having the following. So P1 represent for proportion of success for population 1 and so on. So P1 minus P2. So this is 95% confidence interval, and we are having the following. The sample differences is a negative value. Standard error is 0.018. So this is for people who compute by hands, you're having this. And the lower limit is a negative value, and upper limit will also be a negative value. Okay, so it means so if it's negative value right here it's not really like it's lower than 0, right? So you can interpret that if you are compute, let me see. Okay, so you just found this value, then whatever that they estimating, you just plug this value in. So let me check. It's negative because we are putting the P1 smaller and P2 is bigger, then we do subtraction. And again, it really doesn't matter, like P1 have to be A70 at all. So what comes first, you write first. So the year is 2002, go first, we write that first. Okay, so let me go back. See. Close this one. So that's the idea for you to run StatCrunch. And let me see if they add another example for us to look at it so that you can see clearly. So we did talk about here, right? So next, right here I did talk about this. And here is the example that hopefully they having the value. Right here they say construct 95% confidence interval of that. Okay, so this is easier. See, they given us that. So now they given us in August 2014, we're having the random sample of 2002 and 3,748 scientists. Okay, if the space station has the good investment of the US, of the non-scientist poll, we have 64% said that the space station has been a good investment. Of the science poll, 68% said that the space station has been a good investment. So they given us two value p hat right here, 64% and 68%, corresponding to 2002 for 64% and 3,748 for 68%. So that is look like the number of in order to figure out the number of success we should convert to, right? So let me look at here. They checking for the central limit theorem with all of this step. So that's satisfied. And then, so we find the number of success by taking the percentage, 64% multiplied by 2002 to figure out the value. So 1281 for the number of success for P1. And non-scientist is that amount, and scientist will be this amount. So we do the same thing. We got this time that sample, right? We're having 2,549 as the number of success. So I plug it in. So when we plug it in for 2, so see that, so this number and that number look like this is smaller than this number, correct? Right, so 1281 is smaller than that. It doesn't matter, it's still okay. So when you run StatQuant, you click 95% confidence interval, click compute. We're having this following value. So here's the meaning. So the interval that we did ahead of time with negative value, we don't include the 0, right? That's what if we don't include the 0, so both value are negative. The population proportion are different, and P1 less than P2. So in that case that we are talking about in earlier example, right? We run StatQuant for earlier example, so that we conclude P1 less than P2. It's obvious that P1 less than P2, and it's obvious that they are different. So that's if the interval is both negative. But the case that we are, if the interval contains a 0, it means the number like maybe like 1, 2, for example, 0 will be in the between. So that contains a 0. And the population proportion might be equal, like they having the same population proportion, the same. And I'll go back to the example that we did for, let me see, at the beginning, we're having negative, right? For this one case, we have negative value. So it means the population proportion of in 2002 less than the population proportion in 2009. So okay, it's changed, right? It changed because it looked like P1 less than P2 as the conclusion. Differ just by chance because the population proportion is the same even though. So you can answer that question by saying that, okay, that's a negative value. So we conclude that the number in 2002 is less than the number in 2008 and 9. So we're doing this, and here is more interpretation, this is more conclusion. So both values are positive, then population proportion are different, and but P1 greater than P2. P1 represent for the population proportion for the first group greater than the population proportion for the second group. That's what it means. Okay, for our confidence interval, so pretending is the value is negative. The interval does not contain a 0, so there is a significant difference in the population proportion of P hat 1 minus P hat 2. So we can conclude that P1 less than P2. Okay. In other words, this one just a sample, just the example. Okay, this is not the actual. Let me see if it's. Oh, I think this one is the actual. Let me run that one to see if it's the same. Okay. So let me see. Go back to the PowerPoint, looking at the stat quants that they run. Right here, they got this and they got this value. Yes, I see it. So when they're running it, they type in correctly, and we have lower limit and upper limit like this. And they draw out a conclusion. So remember, when we're talking about percent, you can ignore the negative. But the negative represent for you are comparing if it's bigger, P1 is bigger or P1 is smaller than P2. So in other words, for this case, the proportion of non-scientists who believe the space station has been a good investment is less than that proportion of scientists who believe so. So the plausible value for the difference in population proportion is between 1.4 and 6.6%. Okay. So it looks like if you don't thinking about the negative value here, just setting up the difference only. And when we're talking about the actual percent, then you can thinking of like, okay, you convert this into percent, you got 1.4 to and 6.6%. So in this one, they're talking about, let's see, extracting natural gas through that fracturing and fracking and a control practice. So look like they're having a story right here, and they given us P1 represent for proportion for Michigan resident favor fracking, and P2 represent for Pennsylvania resident. So look like they have two different groups, and a 95% confidence interval for the difference in the population proportion. They compute like that. So right now it's look like they just given us the information. They don't asking us to compute that. So if this happen like a minus and a plus combined, this look like they contain zero, right? You see that? So negative value in here, zero, and then above zero right here. So this contains zero. It means they might be equal. Okay, that's maybe the question that I want to ask. So since the confidence interval contains zero, we can conclude that there is no significant difference in the proportion of residents who support fracking in these two states. So this example is actually just give you the conclusion of the result. So if it's on the test, I might ask you question 1, example 1, and example 2, like this example. Okay, but I'm not sure. It might be on the test. Okay, and this one similar. So you need to know how to look at and compare these two. I think that's it for chapter 7. It's very good, nice exercise. I don't know if there is a lot of like this type of question on your homework, but I hope this helped. I think I'm done with 7.5. Again, if you have questions, please email me.